In this video, you will learn how to solve 3 different types of puzzle problems. First of which is a digit problem, second is an age problem, and third is a fraction problem. So looking first at the digit problem. We have here that the sum of the digits in a 2-digit number is 9. The new number, when the digits are reversed, is 27 more than the original number. Find the original number. It's going to be very helpful if you create yourself a table for these types of problems, where in the rows we have the original number and the number with the digits reversed. Now for the columns, we have the different places, so like with a tens place and the units place, because if it's 2 digits, that's how many digits we have. We have the tens place and then the ones place. So here we have tens and ones place, and then the value, this is the value of the whole number. Alright, so the tens place in the original number is t for 10 and then u for units. Now the value of that number is found by taking 10 times the tens place plus 1 times the units place. If you don't understand that, let's use an actual example. So this is not the number, but for example, if we had the number 54. Alright, so just looking at the numbers 5 and 4, right? The tens place and the ones place. If that's all we knew is 5 and 4, we can determine the value by taking 10 times the 5 and then plus 1 times the 4. That's the tens place, and this is the ones place. So 5 times 10 is 50, plus 4 is 54. Right, so that's what we're doing here. We're taking 10 times the tens place, that number, plus 1 times the ones place. Alright, so that's where this comes from. Now we're doing the same thing, but with the numbers being reversed. So we switch the tens in the ones place. Alright, so instead of a t, this is going to be a u. Instead of a u, this is going to be a t. We just switch the tens in the ones place. Alright, so the value is the same thing. This tens place is 10 times u, plus the units place is 1 times t. So we have 10u plus 1t. Okay, so from here, we can use this table to set up 2 equations. So to begin, we look at the other information that we have. So here it says in the first sentence that the sum of the digits in a 2-digit number is 9. So sum is 9, which means if I add these digits together, the t plus the u, tens place plus the units place, okay, add those together, we're going to get 9. So for example, it could be like 45, so 4 plus 5. Or it could be 63, so like 6 plus 3. Something like that. Alright, so that is my first equation. We see it typed up over here. Alright, so that came from the statement that the sum of the digits is 12. Okay, next we know that the new number, when the digits are reversed, is 27 more than the original number. So this one is a little more difficult to create an equation from. But if we just break it down piece by piece, it says the new number when the digits are reversed. Okay, so looking at that phrase, the new number when the digits are reversed, that's going to be right here. The 10u plus t. Alright, 10u plus t. And we're looking here because it's talking about the value, right? The new number when the digits are reversed is 27 more than the original number, so it talks about value. So that 10u plus t, it says, is 27 more than the original number. So is means equals. So is 27 more means you're adding 27. So you're adding 27 to the value of the original number, which is 10t plus u. And just be careful with the plus sign. It looks kind of like the t a little bit. So this is my second equation, which I'd like to maybe rearrange this to get the t and u on the same side. So let's bring this 10t and the plus u to this left side. All right, so let's subtract 10t over and subtract u over. So subtract that over here as well. That will bring that all the way to the left side, and we'll have 27 on the right side. So we have 10u minus 1u, that gives me 9u. And then we have 1t minus 10t is negative 9t. And that's equal to 27. All right, so that is my second equation. And from here, let's rearrange the t plus u, so the u comes first. So we have u plus t equals 9. All right, so here we have two equations. Everything is lined up, and the numbers are by themselves on the right side. So at this point, there's different ways I can solve this. And actually, if I look at the first equation right up here, notice I can divide everything by 9. Right, 9 divided by 9, negative 9 divided by 9, 27 divided by 9. If I do that, I'm going to get u minus t equals 3. So I have u minus t equals 3 for the one equation, and then u plus t equals 9 for the second equation. All right, at this point, it's going to be pretty quick to solve, because here, notice the t's and the u's would cancel. If I subtract the u's, those would cancel. If I add the t's, those would cancel. Addition will be a little safer to work with, because you're not working with the negatives. So from here we just add these together. So negative t plus t, those would cancel. U plus u is 2u. And then over here, 3 plus 9 is 12. So 2u is 12. Divide both sides by 2. U is 12 over 2, which would equal 6. So u is 6. That's the units place. I can plug that into either equation and solve for t. So looking back here at the t plus u equals 9, we said u is 6, so t plus 6 equals 9. So solve for t, subtract 6 from both sides, t would equal 3. So the tens place is 3, the units place is 6. So the original number would have been 36. When you swap the numbers, swap the digits, it would have been 63. And notice that 63 is 27 more than the original number. So we have the correct solution. Our answer for the original number would be 36. Next, we have age problems. Here it says Luana is 3 years older than Kona. 4 years ago, she was twice as old as he was. Find their ages now. So to begin this kind of problem, I again would like to create a table. So in the table, I want the two different people. So here I have Luana and Kona. Those are my two rows. And then for the columns, we want the age of each of them now. And then we want the age of each of them 4 years ago, because that is the other thing that I know about their ages. So from here I can fill in the table. All right, so now Luana's age we don't know. We'll call that L for Luana. Same for Kona, we don't know his age, so we'll call that K for Kona. So 4 years ago, Luana would have been 4 years younger, right? So I do L minus 4 for Luana's age 4 years ago. Kona as well, 4 years ago, his age would have been K minus 4. So 4 years less than he is now. So we have the table completed. Now we just need to create equations. So it says right now, Luana is 3 years older than Kona. So Luana is L, is equals 3 years older than Kona means I take Kona's age and add 3. So L equals K plus 3. That is dealing with their ages right now. Now we have 4 years ago. It says she was twice as old as he was. So looking at their ages 4 years ago. So 4 years ago, she was twice as old. So if what that means is that Luana's age, if I multiply Kona's age by 2, that would give me Luana's age. So like for example, let's say Luana's age is 12 and Kona's age is 6. Alright, if she's twice as old, that means we have to take Kona's age, so this is Kona, and multiply by 2 to make them equal, right? So same idea. We take Luana's age, which is L minus 4, equals Kona's age, we don't know, but it's K minus 4. We multiply by 2 to make it equal. Alright, so that is my equation for the second one. So L minus 4 equals, and then 2 times K minus 4. So there's different ways we can solve, but if we want to use our addition or subtraction method, we want to get L and K on the same side, and the number on the right side, and then make sure things line up. So for the first equation, I'd like to bring the K over, so subtract K from both sides. So now we have L minus K equals 3. Okay, for the second equation, we would want to distribute. So 2 times K and 2 times negative 4. That gives me 2K minus 8, which we see right here. And then we want to bring this 2K over. So make sure the L and the K are on the same side. We can do that by subtracting 2K. So that will cancel. I now have L minus 2K minus 4 on the left side and negative 8 on the right side. Then let's bring this negative 4 to the right side. We do that by adding 4. So now we have L minus 2K equals negative 4. So those are my two equations. And we see that typed up right here at the top. So from here, notice everything is lined up. We have L's, K's, and then equals, and then the number on the right side. So at this point, I can solve quickly because notice the L's. If I subtract them, L minus L, that will cancel. So I'll subtract both equations so that L's will cancel. And just be careful with the negatives because we have a negative K minus a negative 2K. Well, minus a negative makes a plus. So I have negative K plus 2K, which is 1K. And again, be careful with the subtraction sign. So 3 minus negative 4 gives me a positive 7. All right, so K is 7. So I can use this number to solve L by plugging this back into either equation. If I choose the first equation, I'd have L minus 7. So L minus 7 equals 3. I can add 7 to both sides. L would equal 10. So Kona's age right now is 7. Luana's age is 10. And that is my answer. And I can double check by thinking through if this is true. So the first statement says Luana is 3 years older than Kona. Well, yes, that works. So she is 3 years older. And then 4 years ago, she was twice as old. So 4 years ago, she would have been 6. He would have been 3. At that point, she would have been twice as old as him. So we have concluded that we do have the correct solution. Now our third type of puzzle problem is dealing with fractions. Here we are told that the numerator of a fraction is 4 more than the denominator. If the numerator and denominator are each increased by 2, the value of the resulting fraction is 6 over 7. Find the original fraction. So to begin, I want to establish my variables. So we can let n equal the numerator and d equal the denominator. So that is going to be the top and the bottom. So yeah, don't forget your terms. Numerator is the top of a fraction, and your denominator is the bottom of a fraction. So for example, 6, for 6 over 7, 6 would be your numerator, and 7 is your denominator. And so for the original fraction, we would have the numerator divided by the denominator. So n over d is the original fraction. So at this point, I can begin setting up my equations. And we do that by looking at the statements given in the problem. So it says here in the first sentence, the numerator of a fraction, so n for numerator, means equals 4 more than the denominator, which means I take d plus 4, right? 4 more than the denominator. So equation 1 is going to be n equals d plus 4. And I like to get n and d on the same side, and I'll do that by subtracting it over. So I have n minus d equals 4. Okay, now we can create equation 2. And we do that by looking at the second sentence. It says, if the numerator and denominator are each increased by 2, okay, each increased by 2, the value of the resulting fraction is 6 over 7. So what I do is I use this right here, this n over d for the original fraction. And it says here, I increase both the top and the bottom by 2. So that means I'd take n plus 2 and then d plus 2. And it says the value of the resulting fraction is 6 over 7. So whatever that is, the value is going to be or equal 6 over 7. So this right here is my second equation. N plus 2 over d plus 2 equals 6 over 7. So at this point, I want to simplify this fraction, and I can do that by cross multiplying. So if I do 7 times n plus 2, that's going to equal 6 times d plus 2. Alright, so notice the fractions are gone. It makes it a little bit easier to work with. Alright, and then I can distribute. We get 7n plus 14 equals, and then 6 times d plus 12. Alright, and then from here, we would like to get things lined up. So bring the d over with the n. I do that by subtracting 6d. So that will cancel. I now have 7n minus 6d plus 14 equals 12. And then let's subtract the 14 over to bring that with the 12. So now I have 7n minus 6d equals 12 minus 14, which is negative 2. So that is my second equation after rearranging. And we see everything that I just did typed up over here, and we have my two equations right here. Alright, so at this point, I need to solve this, and I can do that by using the addition or subtraction method. But to do that, I need to multiply one of the equations by something so that the variables will cancel. So if I look at the n's, for example, here we have 1n, here we have 7n's. To get these to be the same, I can multiply this top equation by a 7. So that would become 7 times n minus 7 times d equals 4 times 7, which is 28. Alright, so that's my first equation. And the second equation will stay the same. And I chose that because now if I subtract the two equations from each other, the 7n minus 7n would cancel. And we have negative 7d minus negative 6d. Be careful with the subtraction of the negative. We have negative 7 minus a negative 6, which becomes a plus 6. So negative 7 plus 6 is a negative 1d. Then equals 28 minus negative 2. That becomes a plus 2, which is 30. So negative d equals 30, which means positive d would equal negative 30. Alright, so from here, I can find n. So I found d, just need to find n, and I can do that by plugging into either equation. If I pick the first equation, we would have n minus, and then minus d, so minus a negative 30 equals 4. Minus a negative makes a plus, so I have n plus 30 equals 4. Solve for n by subtracting 30 from both sides. We now have n equals 4 minus 30, which is negative 26. So my answer is that n is 26 and d is negative 30, which means that the original fraction would have been negative 26 over negative 30, which you can reduce. But there's actually no need to reduce because this was your original fraction and this would be my actual final answer. And yes, it could reduce because it says here if you increase the numerator and denominator by 2, the value is 6 over 7. So we can confirm that to be true by adding 2 to the top and bottom. That'd give me negative 24 over negative 28, and that would reduce to give me 6 over 7. All right, but the original fraction would have been right here. All right, if you try to reduce and then increase by 2, it's not going to work to get the same fraction back out. And that concludes our lesson for today. We will see you next time.